Okay, still just getting set up here. Hope everyone is doing well, if anyone is there. And we are on the 7th live stream now for the chess engine project. So forgive me while I get set up here. But yeah, if you're watching this, I hope that you're having a good week. And hopefully you have some time off for the holidays soon. But yeah, chess engine. So I think where we left off last time was trying to figure out exactly how we were going to figure out when a king was in check after we've done the pseudo-legal move checking. And so the way that the pseudo-legal move checking works is that we basically checked every possible square that a piece could move to, with the exception of whether or not that actually left our own king in check. And what I realized was, sorry, just going to get some tunes going here. What I realized was that checking whether or not our king is in check is a little bit more of a complex problem than I had designed for initially. And we can look at that with some code and then take a look at how I've solved it for version 1. So let me figure out how to share my screen here. Hopefully this will work. Okay, and hopefully the audio is working as well. Sorry, I'm going to move the microphone real quick. Yeah, so got my external keyboard set up right now, so I'm going to be doing a lot of reaching if I don't adjust this. Also, I may be eating my dinner on stream tonight, so forgive me for that. But yeah, so let's take a look at some code, actually. We can just open this up in Vim. And I'll try to make the font a little bit bigger as well. So we've got this position module, which is really kind of growing out of control at this point. I have an unresponsive terminal. This is what happens when I try to resize tmux sometimes. We'll get there. Come on. Also, I upgraded to Big Sur within the last couple of days, and that's been going just fine, I think. But I have destroyed this terminal. All right, so we're going to take a look at that position. And actually, we're inside of the wake directory now. And we're going to take a look very quickly at the position class, or position module, which contains the position class. All right, so this file has grown a little bit bigger than I would have liked, but maybe in this stream we can take a look at some of the ways that some of this stuff could be made more efficient, and maybe address some of the to-dos up here as well. So last time I talked about the fact that since we're doing pseudo-legal move checking, which is the concept of checking all of the legal moves a piece can make with the exception of checking if it leaves your own king in check, which would make it an illegal move, I needed a way to effectively reset the state of the board back to the previous state before the engine effectively realizes that it's an illegal move due to this self-check. And so let's see if I can actually also get this going. All right, so the design pattern that came to mind in the case of where you need to sort of effectively have like a type of transaction that you might want to reset was the Memento pattern. And to be completely honest, I've never used it for any other purpose on any type of serious project. I'm familiar with the pattern basically in name and concept only. So it seemed like the right approach to go for the prototype version of the engine that we're building right now. And so that's what I've implemented. So the way that this works now is we have our MakeMove method, which I think will ultimately be extracted from the position module into something more functional, but for now it's an instance method on position. And what we do is, before we execute any of the logic that we're going to do to updating bitboards and updating attack bitboards and evaluating the legality of the proposed move that gets passed to MakeMove, is we set a position state memento. And the idea with the memento, this is a really simple implementation of it. We don't have sometimes there's a even higher order of an abstraction over what I'm implementing here called a caretaker. And the caretaker effectively keeps track of, it can keep track of like an array of mementos or maybe a linked list of mementos or something like that, so that we could track state over time. In this case, I'm getting a fresh memento created each time we make a move, and now I may change that in the future to where we use the memento for more than just, sorry, I'm going to make sure this other window is open as well. Okay, cool. So a memento at this point is just being used to store the state of the position before we go and basically make all the changes to position that we need to make further decisions. So it's like taking a snapshot of the current state. So what we do is we do a deep copy, in this case, of the dictionary representation of the position instance that we're working with. And if we look at the initializer for position state, it's just basically a DTO. It is a DTO. It doesn't have any behavior on its own other than to set these backing attributes, in this case, that are the same as the state representation on position itself. All right, so in MakeMove, here's the logic that we have so far. First of all, if it's not a legal move, and we can check as legal move in a moment, then we immediately just return this new type of object that I've created since the stream called a move result, I think. In any case, there are a few different little factory methods for creating different move results. If it's a capture, we reset the half move clock, which was a concept we talked about last time. We remove the opponent piece from the square that we're moving to, some logic for en passant capture, and then we reset en passant capture to false. This is super procedural, so forgive me for going sort of line by line through the logic. If we are a white pawn, then we always set our half move clock to 0, and the reason that we do that is because a pawn move is a non-reversible move, and so anytime there's a capture or a pawn move, we reset the half move clock. And that's due to the fact that there's something called a 50 move rule in chess, where if either side makes 50 moves, if 50 moves have been made, then either side can claim a draw. And technically, it is a draw after 50 moves have been made without a capture or a pawn move, which are the sort of irreversible moves in the position. So if we just move a bishop back and forth 50 times on both sides, then it's a draw. So that's why we keep track of this counter. All right, then we remove a piece from the piece map. If it's a promotion, we have a method for handling that. And right now I'm just taking the promotion input from standard in. If it's castling, we move the rook around for castling along with the position that we move the king to. So castling is executed by setting an instruction to move the king from its current square to its castling square. And we can do that king side or queen side. Then we increment the half move clock and the half move. The reason that half move is a separate attribute here is because of the fact that I actually use this to determine the current move in the game. And in chess, a single move is basically both sides have moves. So move 1 is white moves and then black moves. And so I just use integer division by 2 on the half move to get the current move number. All right, so then, yeah, castle rights. The way I'm representing castle rights is an array for either side in a dictionary of like 0, 0 for white. We can take a look at that actually. So So like 1, 1 for white would be that white is allowed to castle on both king side and queen side, and then likewise for black. Okay. And here we say if castle right 0 or castle right 1, which would be, what is this? So castle right 0, castle right 1. Oh, if we have castle rights on either side then, so 1 is that true, that we have castle rights, then we have to adjust them and look as to whether or not we have rights. We can get into that. Anyway, we work our way through this. We have some en passant. Ultimately, here's the part that I wanted to get to, that we update the position bitboards and we update the attack bitboards. And this is after we've already said that the move is legal and everything. So what the trick was that was discovered during the last live stream was that we wait until we get here when the board state has, when we've already said, hey, this was a legal move. This is where the pseudo-legal move checking is sort of needs to be reconciled with the rules of chess, which is that a truly legal move is, of course, also not leaving your own king in check. And it was up until this point that the boards actually are not updated, the bitboards themselves. So the position and the attack bitboards. So these get updated, and then basically we have this evaluate king check, which we'll look at. And then if evaluate king check mutate state on the position instance to say if the king is in check for the particular color. If it is in check, then it's not a legal move after all, and we have to reset state to the original position. So this is where the memento comes in handy. And the memento pattern that we can take a look at that really quickly. Refactoring Guru memento pattern. So I implemented a sort of a sloppier version of this. Sloppier in the sense that I don't have a, let's see here. You know what? I just want to look at the memento pattern description rather than the implementation, because we have an implementation that we can look at. The idea is that we need to be able to send a command back to, in this case, it's showing like a history stack, to reset state to a certain previous state. And so, yeah, it might make sense to do that using a stack. What's up, Alvaro? It's good to see you again, of course. A lot of good updates since last time you joined us that I did off stream. So we're just reviewing that really quickly, talking about how the memento was implemented after all. And except for the fact that technically the way the memento pattern is described here, again, is having like a stack of history that we could pop off of. We may actually use that concept to track the state of the game. And actually, Alvaro mentioned this as an idea late in the last stream, that we might track the game history using the memento objects, which themselves are just these DTOs that say what a position is. And I think that's probably a good idea. Because a position can then just be reconstructed from the DTOs, and we don't need to keep some like big stateful complex object with behavior in a stack somewhere. We can just keep the DTO and rebuild from that state whenever we need. But I'm also thinking maybe even just keeping the FENs, which is of course much smaller. If we can just keep an FEN string in the stack and then pop from that if we need to, and rebuild the position dynamically from the FEN, which is arguably not even a better idea than just keeping the Python object, especially for the prototype version, which this is. All right. Yeah, so if you want to read more about the memento pattern, it's in here. Again, the way that I implemented a cheap version here without the history or the caretaker objects was just to have this reset state 2. And then all we do in Python is I just deserialize from the dictionary representation of that memento position that's been saved and set adder on the current instance for all of those properties. And the effect is that we, for any state that's been mutated by the updating of bitboards and the position, it just gets set back to what it was at the very top when we call MakeMove, where we created this sort of backup copy. So that's part one of the biggest changes that have been made. Part two was the how do we check if a king has a legal move? This was, again, more complex than I naively assumed it would be. Also, if anyone ever wants to play chess, oh, looks like I do have a challenge. That's sweet. Oh man, I hope this is from the stream. If this is Antin, who frequents the stream, what kind of time controls do we have on this? I'll keep it open. That would be great if Antin's here and wants to play. While that's going on, I will also open up an analysis board. Oh, and it's infinite time, so that's cool too. So we don't have any time controls. All right. All right, so let's demonstrate first for people who may be less familiar with chess, like this concept of a pseudo-legal move, just to get caught up here. So what the engine was allowing up until last stream was like the knight. It's just checking what legal squares the knight has. And we do all the legal square representations with bitboards, and there's actually pre-computed bitboards for all of the positions a knight can move to, all the squares a knight can move to in a position. So, and not in a position, but from any square. So it's purely deterministic where a knight can land, depending on whatever square it's on. And the only thing that a knight needs to check for is whether or not its bitboard intersects with the bitboard of opponent pieces, in which case the knight could capture, or if it intersects with its own color pieces, in which case it's just an illegal move for a knight. And then we do all the other stuff to keep it tidy, like mask off the edges so that when we wrap, so we have this bit mask on the left or the right side, depending on which side of the board the knight's on. Okay, so that's all good, but here, black's knight is what's called pinned, or absolutely pinned. And it's pinned because if the knight were to move, it would leave its own king in check from the white bishop here on b5. Looks like Anten's here. Thanks for playing. All right, so Anten's going to play a Pirtz opening. It seems like a lot of people play Pirtz. All right, so yeah, so basically what our engine is doing right now is it's saying, all right, we'll let you move the knight here, and then it checks the complete state of the board in this position. In that process, at some point it checks what squares the white bishop is attacking. And if they intersect with the current position of the other color, which in this case is black, then, or own color, which is black, then we know that this was an illegal move and we need to reset those. We need to reset state. And so that's how it's currently handled. The next thing that had to be done was the following. All right, so let's say black plays here and I play check. Okay, so this was also slightly more complex than I had considered, but I hadn't really considered it very deeply anyway. Here's why it's complex. It's easy enough to determine when it's your turn if you're in check, because you can just intersect the opponent's attack bitboard with your king location. Right, so my attack bitboard has a bunch of squares that are attacked on the white side, and one location for the king on the black side. So we can easily determine that we're in check. But the tricky thing is to determine, like, are we in checkmate? And how do you determine if you're in checkmate? So if you're in checkmate, it means that there are no moves that you can make that would make it such that your king isn't in check. And your first thought might be, well, yeah, so we just check, can the king move anywhere? And missing castle, promotion, and some rules like 50 steps, third time repetition now. Oh, yeah, thanks, Elbro. Actually, we have castling, we have en passant now. I can demonstrate both of those. We have promotion. The only thing that we don't have is 50 steps rule and 3 full draw, so seeing the same position 3 times. I can't guarantee that it's bug-free by any means, but I'll show you the updated notebook in just a moment. So your first thought upon being in check might be like, all right, so we just got to see if there's any legal squares that the king can move to that get it out of check. Like in this case, king e7, for instance, will get us out of check, right? That's true, but that's just one way that we can avoid check. The other three ways in this position that we can avoid check are we can move the knight to block. That's a legal move. We can move the bishop to block. We can move the queen to block. We could also take the bishop. So the thing is about determining whether or not something is checkmate is it's not determining whether or not the king can move on that turn. It's whether or not the king can escape check in this turn. So this stumped me for a little bit off stream, but I have the implementation now, and what's cool about the implementation is, well, A, it's probably extremely inefficient, so that's the uncool part about it. Yeah, I don't have stalemate logic either. Thank you for providing me that as well. But what's cool about what has been implemented so far, or at least I should say what's encouraging, is that I feel like we're starting to move into the move generation, past the move generation stage into the very close to the position analysis stage. So what I do is the following. To do the checkmate search, and also it's my turn against the on 10, and kind of an unorthodox opening. This technically is now changed into a French defense. Normally players would play e4 and then e6, and then if I were to play d4 and then the opponent would play d6, this is called the small center of the French defense, but it's pretty uncommon, I would say. All right, so also at chess club a few years ago when I used to play in Madison, I would play against this guy who played the French defense, and he would always crush me in the French defense, and I'm still like super. I have no idea how to handle the French, so or what am I saying? I mean, I don't really know how to handle any opening particularly well, but it seems like I always used to get beaten in the French. Thanks, Antin. All right, so now that we've quickly covered some of the problems, let's take a look at what we can do so far. So this is the good part, and hopefully the notebook is not going to reveal any bugs. All right, forget about the... All right, so we have FENs. I think there's a bug in FEN in the legality checking of king or queen side, but I'm not too worried about FEN representation just yet. All right, so we're making some moves here. Here's the current position after those moves. This is a standard e4 opening. So here we're going to play bishop b5. This is the Roy Lopez or Spanish opening, which is probably one of the most, I don't know if it's the most famous or second most famous after the Sicilian and e4. And then d7 to d6, common move, and white king e1 to g1. So the king is on e1, but once it moves to g1, that's a castle. So you can see that that's been taken care of. Hudson, there's no need to apologize. When it comes to chess, I think we're all learning to a certain extent. All right, so we have castling. That's great. That seems to be working. I haven't tested on queenside yet, but the logic should hold. All right, so then we have knight c6 to d4. So we take a look here, or what did I do here? Piece black, knight c6 to d4. Oh, that's right. So c6 to d4 is our illegal move. So I'm not printing illegal move anymore because it was getting annoying during the move evaluation checks, but we can see now that knight c6 to d4 would be illegal. That would be the move that we looked at earlier here. Knight c6 to d4, we can't do that because that's self-check. So the game resets and doesn't let us update. Looks like Anten has played interesting. He's played a move that is very aggressive, kind of maybe slightly weakening the king side, but still playable, it looks like. Oscar Boy, hello. All right, so I don't really want to lose the center pawn here, but I feel like it's fine to do so at this point, so I'll just pre-move this. All right, so we can't move knight c6 to d4 because it would be an illegal move, right? So let's try to make a different move. So now we're saying the bishop on c8 can go to g4, so we do that here. And now I can play bishop on b5 takes c6 with check. And if we are to try to move our king to, we can move our king from, this is the king from e8. If we try to move the king from e8 to d7, it would still be in check. And so it actually doesn't let us do this. This was registered as an illegal move, and it just prints out the same position that we just had. All right, but if I were to say e8 to e7, now our king got out of check. The black king got out of check in this case. So check is taken care of. Yeah, so that's good. We now need to worry about checkmate. Ninth grade, right now I'm in college. It's going to take a while for me to read. Yeah, no worries. Thanks for playing. Most of the time people don't even challenge. So I appreciate having someone to play on stream. All right. So here's how I'm checking if we're in checkmate right now. And to be honest with you, I'm going to open up PyCharm instead of Vim at this point. Okay. Bump up the size a little bit here. And on 10 is going to actually give up, or get queens off the board, I should say. I think this might just win a pawn. All right, so here is the evaluate whether or not we're in checkmate up to this point. So if we go up to MakeMove, come all the way back down here to, self king in check and not self dot any legal moves for the other player, then it's checkmate. Alvaro says, one question, the turn is stored as part of the memento, I guess. So on reset, you don't lose track of who needs to move, especially, yeah. That's a really interesting, or it leads me to another interesting point, that that was messing me up a little bit because of the fact that when we're evaluating when we are evaluating whether or not the next player has moves that will prevent checkmate, in other words, get their king out of check in some way, it was tricky to reuse the instance of color to move on the position if I was going to reuse an instance method on the position. So I actually pulled out color to move to also be on move itself. So now it simplified the parameters a bit, so I'm not passing color to move everywhere. Yep. It works well inside position state, but I think it still serves that purpose well. I think I put a comment in here somewhere. Yeah, actually the only place it ended up being really important for now was whether or not we have the wrong color piece that we're trying to move, and this is actually for a technical detail because of the way that move works. Is I thought about the fact that move already has an assignment of the piece, and piece is just a number, and it's the two sets of black and white pieces are disjoint. So in a sense, white already has knowledge, or sorry, move already has knowledge as to whether or not it's dealing with a white or a black piece. And so I put a property on it just to say if the piece is in white pieces, then it's white's turn, otherwise return one for black's move. so there's a bit of redundant state here, but it did allow me to make any method inside of position um, work without depending on the instance state of position as far as the color to move was concerned, which sounds like pointless, but it made it a lot easier when it came to evaluating the other side, if you will, like the other player, and being in checkmate. Yeah, that's right. All right, see you on 10. Sorry that we didn't get to finish our game. All right, so on 10 resigned, but good game. So I think that this probably wins a pawn here. I think maybe it's a little dangerous to open up the center so early, but super glad to get a game in. All right. And if anyone would like to play at any point, I'll keep an eye on the lichess. All right, so let's get to this move checkmate analysis. All right, so we basically say if the other player's king is in check and there are no legal moves for the other player, then that's checkmate. So how do we check if there are legal moves? It's like this recursive thing. We have to come back through the logic that we have in MakeMove to determine if there are legal moves. So the prototype version of this has a relatively large number of has a relatively large amount of duplicate logic, and I've only verified it for the king moving itself to get out of check. But we're gonna uncomment this other stuff, and it's actually in here. So what happens is we say, all right, so we're in check. We need to see if we have any legal moves. And in this sense, a legal move means that it ends without our king being in check. And yeah, I'm up for it, Alvaro. I'll definitely play. Maybe after I uncomment this and see what bugs we have. So, also Alvaro, thanks for joining because I've realized it's probably again super early in the morning where you are, super late at evening. In the evening. Okay, so we say, are there any legal moves? And the way I did this was, the way I do this is I move piece by piece through the board to see if we can move any of our pieces and have the resulting state end up such that our king is not in check. And the trick here is, okay, we have all of our pieces. How do we just randomly move them? And the way that I'm doing it is I'm basically brute forcing our pieces around through their attack bit boards. And the moment that any piece group has a legal move, we return true. So there's undoubtedly more efficient ways to do this. But it seems to be okay for a prototype version. I don't know really what other sort of like approach we can use. Man, 1:30 in the morning in Spain. I will probably be sleeping by 1:30 in the morning here, hopefully. All right, so we go move by move, and what I did here in terms of like a hand wavy way of trying to make this a little bit more efficient was just thinking to playing chess myself and saying like, all right, when my king's in check, typically what are the pieces that most often are blocking it or being used to capture the piece? I mean, I have no idea statistically what that would be. But in any case, I say let's just check if the king can move first. A lot of times, and all we're checking here is whether or not there is a legal move to escape, not whether there's a good one. There's no concept of position evaluation yet. So we just say, can the king move? If it can, return true, and we don't have to check anything else. Then can the rook move? If it can, we don't have to check anything else. The stalemate or checkmate is going to solve itself by working on the search anyways. It's basically either crossing results or none, state none. Sleeping is for the weak. That's what you said last time when I was trying to wrap it up and then ended up coding for like another hour. All right, so I'm going to uncomment these. Here is the way that these steps in the legal moves thing works. So what I do, apologies, this is like phase one of the implementation, but what I do is say, all right, there's a king color map, and this is a map of a tuple that has, dictionary of a tuple that has white's king attacks, which is a bitboard, and piece white king, color black. This allows me to pass in color to move and grab white's or black's side of the board. So king attacks is going to be king color map color to move 0th index, and then the king piece itself is at the first index. If there are no king attacks, meaning that bitboard is all zeros, then we return false. This is going to happen if the king has no attack squares. And we've updated our bitboards up to this point in the MakeMove method. And so our engine is looking at the proposed state from having moved all the pieces. So in that sense, it's kind of nice. We can short circuit a lot of things as we go through the logic here. So if our king has no attack squares to move to, then just return false. Hey, Marcos. Hello to you as well. Thanks for joining from Brazil. Okay. Let's see here. Oscular, have a good night. And Festus, this is an SM7B. Marcos, I'm a big fan of Brazilian music, particularly Tropicalia, like Caetano Veloso. All right, so let's see here. We don't have any king attacks, just short-circuited end. Otherwise, I need to make a copy of the piece map so that we're not mutating, I'm not risking mutating the current state. And I get the king from square here. And this is silly. I just pop it off of this set. I know that the set is always going to be size 1, so I don't really need to pop it out of the set, but refactoring will come later. I get the king squares from the bitboard. So let's see here. Yeah, that sounds good. I'll just try not to leave a huge mess, Alvaro. Thanks. Here's how we get the squares from an existing bitboard. The way this works is, this is again not efficient, but we have this numpy UN64 bitboard. We can very easily represent this 64-bit integer as a binary string of zeros and ones. This is going back to the very beginning. Now, to get the indices of where these pieces exist, I just need to get the index of every place that that binary string is hot. So basically, I just enumerate through the string representation of the bitboard, return those indices, and those are the squares that particular piece is. Oh yeah, that's really good stuff. Stuff from the 60s, although Caetano, I guess, is maybe even still playing. Or is he? I'm not sure. Apologies if he's not, or if he's... yeah, I'm not sure if I pronounced Gilberto Gil's name correctly, but that's another beautiful musician. Os Mutantes, I think, isn't that another band? But anyway, I just can't. Sometimes I can't get enough of the Tropicalia records. All right, so we got the king squares from the bitboard by just serializing out that binary string representation. I don't think we can really have string operations in the engine and have it be very efficient, but when we say 4 square in king squares, there's always going to be 1 square that the king is on, but this works for the other pieces, the other piece sets, of which there are more than 1 piece on the board often. We create a move, and then we pass this to an evaluate move function and say, if that's not an illegal move, return true, otherwise return false. So we do this over and over again for the different piece groups. The only one that's a little bit different is the pawns, because we need to do a union of the pawn attack bitboard and the pawn motion bitboard. But that works. Oh, Daniel, that's a really good question, actually. The only reason I'm doing this, Los Mutantes, Marcos, yeah. It's been a while since I listened to some of this 60s music from Brazil, but good stuff. And Daniel, to answer your question about Python, the reason that I chose Python was just because it's easy to build things quickly, I think, for me personally in Python. And yeah, Jupyter provides a nice sort of like REPL environment for me to prototype ideas and sort of get the major bugs out. And since I'd never built a chess engine before, I just went with the language that I could prototype quickly in. Could have also done it in C# for sure, but I kind of just felt like just messing around in Python for this for a while. I do plan on ultimately rewriting it. We'll see. I mean, that's like the plan for now is to do V1 to kind of learn how chess engines work, and then maybe V2 in Rust or something else. More performant than Python, because Python's going to cause us to suffer from a performance perspective. Although, at the very least, using NumPy and a native C type to do our bitboard representation should be a decent approach. And using bitboards in general, I think, are going to make some of the operations that we're doing a little more efficient. But there's inefficiencies all over this code anyway, and the fact that it's written in Python is going to be another general performance issue. Rita Lee and Ne Mato Grosso. Nice. Isn't Mato Grosso? That's a that is like a district or a municipality, right? In Brazil, if I'm not mistaken. Also, apologies. I'm going to eat a little bit of them. Yeah, Marcos, I use Jupyter as a REPL for prototyping ideas, getting like just quickly using it to debug. I'll push my latest code to the repo. I'm not sure what I did here. And if anyone's joining and hasn't seen the other parts of this series and you want to check it out, Mato Grosso is a place. I see. Is that southern Brazil? Central? It must be like central. Okay. I only remember this because I was looking at a map of Brazil recently. Okay. It's a state. I see. Okay. So if anyone wants to scope out the project itself, it's over here at my GitHub, /bakeengine. And I'm going to pull in the branch I have for Checkmate. I think that it's okay, although there are probably some bugs to work out now. Let's just go ahead and merge it. So main's still kind of a mess. Yeah, when at the moment, since I'm the only one coding on it, it's like I should have just squashed all those commits and just said implemented initial checkmate. All right, did I actually pull this? I was looking at chat while I was doing this. Yeah, I'm sorry about the bad commit message. And I got to remember Sid Hans created a pull request for some documentation. Central, Marcos, I see. Okay. Alvaro, if you ever want a challenge, I'm up for a game. In the meantime, I'm gonna look for a bug here. So it looks like, I mean, the move checking is still working just fine, as is taking a piece to get out of check. Now what happened here? We might have a bug, because it looks to me like we made move 10, which was black king e8 to e7 to get out of check, and then we made a move black pawn b7 to c6 to take the bishop, and that's definitely not our turn. So we might actually be running into what Alvaro brought up recently. Alright, so here's what I'm going to do to check this. I'm going to replay everything up until that position, and then we're going to check the state on position. Okay, so white takes and black is in check. Color to move is true, which is 1, which means black. So that's true. It is black's turn to move. So black moves. And then I can just grab color to move off of position. We want color to move here to be false. Okay, it is false. So maybe it's the case that I'm just not checking that it's an illegal move to move a color that's not yours anymore. Sorry, I got the wrong thing here. True. Okay, so it's switching properly, but I need to and I need to make sure that it's still illegal to move a piece that's not yours. That's funny, Alvaro. That's the dangers of coding on a live stream, is that like I'm doing all these hacky things just to get through it for the time being, and maybe not showing my best, my most polished work. Nice, Marcos. That I started live streaming updates to the library project, which I was not really happy with the way that that ultimately turned out a few years since a few years had passed since the first version, to sort of bring it up to speed to .NET Core 3, and then of course throughout my slowness in actually recording the live streams to update it, then .NET 5 came out, and now I might as well just update to .NET 5, which isn't that different from .NET 3 as far as the level of the API that we're using in that series. Okay. So it's not illegal to not move your own piece anymore. You need to make sure that that's the case. And we have move color now, so what we can say is if not move.color is equal to self.color to move. Return false, and I thought I had this somewhere. It's wrong color piece. Oh, I just somehow missed his wrong color piece. So we're going to throw that back in. guess we pass this move. And then who knows makes it live. Yeah, Alvaro, also feel free to bash away. I can take it. It's no problem. This like streaming business and like pair programming is a lot of fun, and it's weird because like I'm coding and like just talking to you through chat, and like it's like a one-sided pair programming where it's like I have all the control to make a huge mess if I'm not paying attention. All right, so I got this illegal move result helper method now. And I'm probably gonna, when I actually implement proper logging, which I think I'll still do proper logging even for the Python prototype here, I'm going to remove the print statements. And so in fact, in most places here, I've removed print already, and we'll do proper logging. And then I can set a log level. And then when I'm not wanting to see stuff pop out in the logs or in Jupyter Notebook, we can just set a different log level. Like we'll put log level debug on all this stuff. Maybe log level info on. All right, let's see. Let's see. Oh, nice. Is this you, Alvaro? You're on 501? All right, so let's see. I'm going to go ahead and run the whole kernel again, restart and run all. That's the other thing I love about Jupyter as a REPL, like a debugging platform, is that you can like immediately rerun and save everything that you've done previously. And in fact, still I was able to capture. So what kind of time controls? All right, so we have proper 5-minute time control. So I'm going to take a proper 5-minute break here to play chess. And someone's playing Sicilian against me. Let's see. So we're playing a Sicilian now. Ooh. Oh yeah, I got you, Marcos. All right, so now black has pinned my knight here. So I'm gonna do what I can just to shore up the center a little bit. I'll probably get crushed here as well. I wasn't sure what f6 is, but okay, it wants to strengthen. It's basically preparing e5 here. I'm going to ask the bishop where it wants to go. Probably h5, I guess. Keep the pressure. And I'm not so sure that I want to play g4. Playing so quickly. Knight e7. Where's that knight going? Wow. Okay, I gotta find a good spot for my queen, which is struggling to find its purpose. Looks like a pretty good move, actually. Alright, so what's my idea here? My opponent's idea is to play b4. If I play c3 feels, well, it is a blunder, actually. This bishop is really annoying me, but it would weaken my king side, but I've got to do something about it, I think, to free up some of my pieces. I'm banking on the fact that f6 was played, that I can also weaken my king center a little bit. And now I want to get my knight to a happier square. So I want to play knight h4. I'm afraid if I play queen e3, just b4. Maybe my opponent will overextend. Now b4 almost certainly. Apologies for eating on stream. So once this game is over, I need to determine why we were able to take here as black after we've also just made a move with our king. Oh wait, king. Oh no, maybe we're good. Let's see. Yeah, it was check, black king moves. No, maybe not. Need to revisit that. Hey, Augustina. Okay, so I thought b4 was going to be played here for sure. But as it wasn't, I'm going to try to play solid? Question mark? I think the rooks belong on b1 and d1. So black's bishop is looking like it's having a little bit of a hard time, but it has some ways to get into the game. Like for instance, I might even already be losing a pawn here. No, actually, I don't think I'm losing the pawn, at least in the way that I thought. I thought that queen a5 was losing the pawn. Queen a5 takes, and I can just take back. Alright, so I said I thought that the rooks belong on these squares, so that's where they're going. And then I'm going to try to reroute my knights. Probably shouldn't just be saying my plans on stream, but there's a 30-second delay. So as long as if my opponent wants to pay 30 seconds to hear my plans, they're more than welcome to. So this worked, right? Why didn't this work to say that it wasn't my own turn? Let's go back to MakeMove. Self that is wrong color piece. I'm just going to print a we'll probably lose on time in the meantime. Alright, so yeah, here comes the reroute. To make sure I'm not like blatantly hanging anything, which I may very well be. Okay. This is where I was worried I was losing a pawn previously. And probably not even the best trade, honestly, because black's bishop was bad. And my bishop was not bad. But I think his queen might have to end all the way back up on c7 after taking this pawn. I was thinking queen a2. No, never mind. I'm hallucinating because I can't. When I did this, I thought that I would just play rook d2, which hangs with the rook on b1. Okay, can I play calmly here? I have to play quickly, but can I play calmly? Things are hanging pawn-wise. But I'm going to put this. Ooh, maybe just b takes c4 here. B takes, if a takes, then what's the plan? Queen a3? No, obviously not queen a3, because I can just take. So maybe queen c2? So I was thinking just rook takes. So I did lose a pawn. I'm about to lose even more than a pawn. Okay, sharpness ensues. I'm just getting mated. Maybe I'm just getting mated. I think I am. Queen takes f2 check. King h1. He's got to be careful too, though. Also, did I have rook d8 check there? I'll have to wait and see. Maybe instead of queen takes a8, I had rook d8 check immediately. Rook d8 check. Oh man, I had rook d8 check. Because rook d8 check, bishop e8 takes queen f7. Okay, so I think I survive. Actually, it's checkmate now, so good game. That was close. I think we both. I think we both had chances. Let's see what the computer analysis says. Good game. Was that Alvaro? That was someone I played a few times. I played Alvaro a few times. Look, he was winning. All right. Should get back to the engine coding. I think maybe my blunder was playing queen takes a8. Let's see. So the threats were real. Yeah, queen takes a8 was my blunder. So just rook d8. Completely missed it. My bad. But that was a really good game. That was a lot of fun. Rook d8 sacrificed the bishop. Yeah. Maybe I could have kept it more fun for us. Run to the middle. Yeah, good game. That was really fun actually. I got super lucky that things swung back in my favor at the end, but that was a really fun game. All right. So, back to the notes. The bug that we have to work out now is why can black move twice after being in check here. So let's get rid of some of the excess garbage in the notebook. And then kernel restart and run on. So move 10, black's king moved, and then move 11, black's pawn moved. That doesn't seem to make any sense. Question is, are we mutating the actual instance self.color to move? And I thought that I removed all of that for the reason. Self.color to move is switched from not self.color to move. Does that happen anywhere else? I explicitly pulled this out of the evaluate move loop because of that reason, that very reason. Oh, I wouldn't destroy you on theory. I am not very good at openings. Although I'm an e4 player, and I know the names of some openings, but I am not a theoretician. Which I found is a really bad thing when I used to play at the club here in the city. Is like I said, I used to play against this guy who played the French, and I'm not a very strong player, just a club player, but people who do study openings tend to get much better positions than I'm able to get in my very limited repertoire. Alright, so self.color to move is only mutated here. This is in MakeMove, right? Do I change it? Other players not move that color, self.king in check. So I definitely reset state. Sidhan, hey, what's up? Good to see you again. I definitely reset state before I mutate color to move. I could just be move this all the way back up here. All right, forgive me for this hackiness. Here's what I'm going to do actually is starting that all. All right, move one. White pawn to move, makes the move. It's white's turn as he's doing that, or he or she is doing that. It's black's turn. It's white's turn. It's black's turn. It's white's turn. It's black's. It's white's. It's black's. What happened here? I said black's turn again, no? Oh, that's good because knight c6 to d4 is an illegal move, so it's still black's turn. Black makes the move. Now it is white's turn to move, and white captures the knight. Black king e7, it's black's turn. Then I say it's white's turn, and black moves a piece, and it's legal. Where's my logic? What is this self.color to move? Let me get rid of this for a second. I got rid of it for some reason earlier. And we're going to do this. If self.color to move, if not self.color to move is equal to move.color. Not your move. Or as Alvaro always says, cheater, not your move. Alright, so that's a little bit more entertaining. And then I'll restart it. I expect to see that here. Why don't we see it? Surely it's something obvious. Black e7 to e8. It is white to move. Moves again. Okay, good. It worked that time, actually, now that I'm looking at it. I forgot that I'm not printing the... Wait. Didn't I just not print this? No? Oh, I'm not printing it to the terminal. Yeah, it's weird, Alvaro. So the way Jupyter works is, and actually the way, if I were to run a Python REPL, like even just the normal Python REPL, and I don't know why Python 2.7 just came out. Like, it must load everything into memory, because even if I were working here, like, and I was going to update the files, like, there's no sort of hot reloading, if you will. Now, Python does create intermediate files, which may be the reason. Clearly, it's an interpreted language, which I think is what you're getting at. Yeah, I will run the whole thing again for sure. But notice that there's this pi.py stuff. So like there is this like intermediate language that's generated every time. Actually, that only gets generated every time I run setup.py to. But in any case. So there's the whole sequence. Is there something in here that you wanted to see specifically? Basically what was happening before was, I need to go back to this. Figure out why. Also, I hope everyone is having a nice holiday week. Thanks for joining the stream. If you want to check out the code, it's in the link in the description, I believe. Okay. So that's looking good. I want to start thinking now about, by the way, I might still check that on Checkmate branch. If I get, doesn't matter, I'll just get C. I gotta make a good commit message so that it's not a bad one. Basically, what did I do here? Check his own piece before moving. Hopefully such a commit would be worthy of a proper project. All right, so we'll go ahead and push this and then check out main branch, git merge, checkmates. Yeah, just git push. Actually, I probably need to git pull. Is anyone still doing Advent of Code by any chance? I thought about streaming that, but I'm way behind. Oh yeah, no worries, overall. Okay, so I pretty much want to start doing evaluation. It feels like I would never get here. Chessprogramming.org. Need the verb, yeah. Gotta capitalize the first letter, need the verb, keep it short. My own commit logs are atrocious. There is an entertaining Twitter feed called Developers Swearing, which I'll keep this a family-oriented show, but if anyone ever wants to see a funny Twitter bot called Developers Swearing and hasn't heard of it, basically, it's a bot that scans open source project commit logs for bad words in English and post them, and there are some really funny ones in there. All right, so what we need to do now is figure out, we can play chess with our engine, by the way. Sort of. I haven't like fully vetted it by any means. But we have check, and there are some details. We don't have stalemates, and we don't have threefold repetition draws, and we don't have 50 move repetition draws. At this point, everything except stalemates among those three is trivial. would be trivial to implement. I'll do that off stream. On stream, I want to take a first dive into evaluation. So let's see here. Getting started. We are past the getting started stage, perhaps. The very first step is to writing a complete bug-free board representation that knows every rule of chess. Now they've given us the warning, but the 3 rules our engine doesn't know is the 50-move rule, although it's provisioned for in the half-move clock. 3-fold repetition, which is, I would say, non-trivial because we need to scan the stack of FENs, and once there has been at least, once we have 3 FENs with the same first segment, then we can claim 3-fold repetition. And did I see the last bullet tournament? That was incredible, I think, with the engines and all the available theory plus the distraction. It's the future, yeah. I think so too. I did watch the Bullet Chess Championship. If you're talking about the one that Hikaru won, right? He beat MVL, I think. And Magnus being upset by MVL in the second to last round. Yep. I think it's the future too, especially since the pandemic, internet chess has really taken off, and with it the faster time controls. Okay, it's extremely important to write bug-free code. The best strategy when starting a new engine is to create a debugging framework. Our debugging framework is Jupyter, but I also need unit tests. And of course, immediately after filming and releasing a TDD in Python video, I do non-TDD in Python when I build chess engine, which was probably not a great idea, but I actually didn't expect it to get this far as it is. Alright, so once you have a nice solid foundation, we have a foundation ready to start learning about search and evaluation. You probably also want to connect it to a GUI. We don't need the GUI yet. We have pretty print functions, but yep, we will need a GUI at some point. And it says we can either use Chess Engine Communication Protocol or the UCI. And I'm planning on using UCI. I am sort of debating whether or not I want to make the prototype UCI compliant because of threading and multiprocessing implications. Not that it wouldn't be entirely possible, it's just that there's a global interpreter lock in Python. It's entirely possible. We just need to be able to take, the thing with UCI is we need to be able to take input from a user even when the engine is running search. Yeah, exactly, Alvaro. But I regret it. I did a live stream like a couple of years ago for a NLP pipeline. This was a fun project, actually. And I did this in TDD on live stream, and why I didn't do it for this series, I don't know. I do not know. Limbus. It's been a long time since I think I put a license on this recently, maybe, but this was a thing I did a live stream for to do sentiment analysis on some stuff. But look at this, 100% code, something to be proud of, I guess. I'm just kidding. Code coverage on the chess engine is precisely 0 at the moment, sadly. So yeah, I'm kind of stepping away from UCI for the moment. Alright, so what should we work on, search or evaluation? Evaluation is determining the value of a position, i.e. the chances of winning. we could see to the end of the game at every line, the evaluation would only have values of -1, 0, and 1. Right? It's a zero-sum game. So search and evaluation are linked, right? Because we need to search for positions and evaluate them. The legality checks for the available squares for the piece selected. Yep. I agree. It's like on, we should look at, I don't want to get too far ahead of myself. And I don't want to look for lead chess in my own. I think lead chess is a closure project. Scala, sorry. I meant to say Scala. Yeah, unlike lead chess, as we all know, like when you click on a piece, you can immediately see what the legal moves are. I mean, we could technically do that as well, but I also suspect that you're absolutely correct, Alvaro, that this may be something that needs to be worked out further. This is actually the entire website and not just the UI. So this is just TypeScript. That's interesting. Okay, well, enough about lead chess, although it's great that lead chess is open source. What should we focus on now, search or evaluation? I want to do the 50 move rule and stuff off stream. Yeah, you cannot, Alvaro says, you cannot evaluate properly a position if you will get mated in one move after you get +11 material, I guess. Yep. There is this idea of quiescence search, which is the idea that you never stop a search on a non-quiet move. A quiet move being one that's not an exchange of material. Because of the fact that if you just, let's say that we set an arbitrary search depth of like, we're going to go, whatever, just say like 3-ply or whatever, and we're going to go to that and then stop search, like that's the horizon. Like the problem is that if we end our evaluation on just that take and we don't look any further, there might be a take which just loses material immediately after that. So I think the idea with quiescent search is that you only evaluate, you stop your search at quiet positions. There are no winning tactical moves to be made. So it's not even just up to capture itself, it's up to a tactical move. Oh, okay. Well, yeah, moves that immediately change material balance and capture a piece or promotion. Obviously irreversible, and static exchange evaluation. So Alvaro, do you have a preference as to whether or not we dig into, I wonder which side it makes sense to dig into more first. Also, it scares me to see pseudocode on here because I'm like, oh man, I don't have a function that does that explicitly, which doesn't really matter. It obviously doesn't mean anything, but when I see stuff that's like make capture, it's like that's not really part of my paradigm so much at the moment. All right, so what's like the standard search algorithm here? Search evaluation algorithm, minimax. Technically negamax, right? Yeah, negamax is the one basically saying that one side's equal to the other. So what goes into chess evaluation? Definitely material, right? So we can assign piece values. By the way, this is entirely non. There's going to be no machine learning involved in the prototype, so it's just purely heuristics. I'm debating whether or not I just take a swing at it, or I continue reading specifically about evaluation. If we go for search, we'll need a material evaluation. Yeah. I mean, material evaluation is easy enough to implement, and we need it anyway. I wonder if I should do that now. Let's read this search tree thing really quickly. The root of the search tree is the position we like to evaluate to find the best move. Get a material evaluation first, yep, and then move to search, and think about how the feedback from search to refine evaluation. I think that makes sense. So we'll go from setting up material evaluation, provisioning for that. And then we'll build a search tree. And it also makes a lot of sense, I think, after the material, like directly after making the material, is to really get a handle on what the structure looks like for the search tree. I mean, we kind of know. I mean, we kind of know what that is, but I mean, like actually implementing it. All right. Constants. Piece. Piece to glyph. Piece to value. Thing is, my pieces are explicitly black and white. Pieces, I mean, separated out. So we're going to do it this way, though. We can do piece down pawn is 1. By the way, sorry, that's really small. I'll make it larger. And this is not C# or anything like it, so we'll use Python syntax inside of Python. Piece dot bishop is 3. Some people say a bishop is worth a little more than 3, but we can get to tweaking the parameters when the time is right. The question is, how long do you think it will take us to build a chess engine that is better than either of us? I would say we're about evenly rated. Piece dot pawn, piece dot bishop, piece dot knight, piece dot rook is 5. Piece dot queen is 9. Piece dot king is, we do like math.inf, is that what it is? Import marth, import math. No, I think it's float.inf. Actually, we can use numpy, right? Numpy infinity. Probably uses something else under the hood than a Python. Then a Python float. Numpy.inf, it's an IEE 754 floating point representation of positive infinity. Use inf because inf infinity, pinf, and inft our aliases for inf. I want to see what the scalar looks like, or whatever it is underneath. It's a float. nt.inf. We don't need to use the Python math module. So I need to remind myself, like, if we're using NumPy, there's probably nowhere that we need to use the Python math module. On bishop knight rook queen. What am I forgetting? That's it. Yeah, if we want to use Memento for the nodes, or not to avoid getting a situation. Yep. Yeah, that's a good call, Alvaro. Like, if we want to use the Memento for the nodes, and I'm gonna have to research more about the node representation. Like, if I'm thinking about the node representation, I'm thinking like maybe. So with the search and evaluation, we have some way that we need to determine like how we allocate resources. So like, are we allocating a particular amount of time to each possible move? Or do we allocate like a maximum amount of time per move and then cut off evaluation if like oppositions are clearly bad after a certain number of tries? And then what does that look like? Does each node just have like, is it just like a hash of the position or some unique identifier for the position that doesn't need to be rebuilt? So clearly we could use like the FEN as like the node, the defining character of the node, because then from the FEN we could always rebuild a position. Or do we just need to know like the actual output value of the position from the evaluation and then be able to revisit the node? Well, in that case, then we would need to be able to reconstruct it if we wanted to revisit it. I almost think like well, that's thinking quite a bit ahead, but I'll do some thinking about that off stream as well. My gut sense is that when we're searching, we would clearly need to cut off if it's obvious that, if it's some way to determine if it's obvious that all moves given a starting move are bad. Like a queen sacrifice is in 99% of cases a bad move, and then sometimes it's a great move. So do proper engines find material sacrifices later than obvious unclear moves? Need to determine. Not the FEN, because you won't know the branch/path. That's what I meant, to avoid recalculating. Yeah. So it's it'd be a fully directed graph. And I don't know why I said fully directed. Oh, because I was thinking fully connected. It will be a directed graph where maybe we have weighted nodes representing the particular, like the absolute value of the evaluation, like whether it's really good for black or really good for white. Actually, we would need the actual evaluation so that, yeah, clearly we would know if black was winning or white was winning. Okay, we'll get to think about that. So now we have piece to value map. We head back into the position. Yeah, do we incorporate patterns like sacrifices? I feel like we kind of, that's such a great question. So like the opposite extreme is like the alpha zero approach, which we're not even remotely doing anything like statistical. We do not have a machine learning model to represent any part of the game yet, but you know, that far extreme would be like we just teach moves, which we have the rules here, and then we have it play, and then have some representation for. I don't know how Alpha Zero works, so I should just stop rambling. But I just mean to say that Alpha Zero was given no heuristics, and it discovers what works through playing itself. Which again, that's like completely different than what we're doing. So, given that we are taking a heuristic approach, do we program in stuff like patterns for common positions where there are ideas of sacrificing? So, like, I guess for anyone else watching as well, there are positions when it's, but again, it's sort of like, I feel like anytime we start to influence, like, what patterns are there, especially as myself as a relatively weak chess player, like I would be able to say, look for this particular pattern and expect to search bishop sacrifices or something like that, or look for this particular pattern and expect to look for exchange sacrifices or weight them higher or something like that. So I guess for people, um, okay, so what's the trap? Yeah, Alpha Zero is a completely different paradigm. Completely. So here, like h3 is played. I did not mean to sacrifice the bishop, but that's kind of the general point. This is not the position. Let's look for the trap. I can look for the trap, opening trap in a moment. But in a game where there's a pawn on h3 and the bishop's attacking this long diagonal, if black is able to maneuver some more heavy pieces to the king side in this case, where white has castled, there are cases in which, as a human player, you start calculating ideas about giving up material for the positional advantage. Sometimes you give up material just to gain initiative. A lot of times you might give up like a pawn's worth or 2 pawns worth of material for the initiative, if you feel like you have an attack that the other side can't prevent from happening. But sometimes you sacrifice pieces, and so sometimes you give up a lot of material, for example, for a mating attack. But I think that, yeah, I can't imagine a case in which, it would be incredibly complex, I think, to sort of figure out constructions like this. I mean, we have bitboards and stuff, so maybe there's heuristics like pawns on the flanks that intersect with sliding pieces, that type of thing. But I think it's going to be tricky. I think it's going to lead us astray if we think about that, at least right now. What's the that's not what I want. Also, Spotify is a really impressive piece of software. I know that this is like not the coolest part about Spotify, but the fact that I'm listening to Spotify on my phone and I can look on my computer at what's playing on my Spotify on my phone and change it from the computer is a nice feature, which is not that impressive, but I guess it is really nice. Roy Lopez, what's like the fishing hook? Yeah, the fishing pole. So here's material sacrifice example, and then I'll get back to assigning the piece values. All right, so this is sort of what we played, right? Something like this. This was what I was thinking of, but I don't know exactly where it comes into play. So rather than, yeah, and obviously it's not a bishop sacrifice there, but castles first, and then, okay, knight g4, h3, and now there's a knight sack here. So, and then takes. The problem is that there's this attack, and so black's given up material in the form of his knight for a couple of reasons, like white is completely undeveloped. So the white bishop at this point is the only piece that's developed. The knight was developed but had to retreat to the back rank. And the other weakness that we could identify heuristically is that white's king safety is bad. So king safety could be modeled as pawns surrounding the king, open files on either side of the king. So maybe in addition to the heuristics that we have for material value, we can also start developing heuristics for positional aspects of the board. So open files, passed pawns. In fact, like stream 1 or 2, we talked about passed pawns using bitboards. And so, yeah, king safety is another one that we could write heuristics for. Alvaro says, you can retake your idea about center squares as danger zone, like a square near the king, and consider, yeah, precisely. Which I just rambled about, and you summarized very quickly there. All right, let's see. So we have piece to value. We could write a property on position to get the current. Get material values. Color. This would be some black material. Do it this way. I want to keep as much state as possible off of the position. Yeah, that's right. Great minds think alike. Let's see. Hey, we gotta have the same idea like once out of every 100 ideas, right? Just kidding. All right, I've only been going an hour and 45. I'll probably go for another 45 minutes. Okay. move my window around a little bit here. Also, why does some material need to take actually, I was going to do it this way, and then like I was going to have this return a tuple, but then I remembered one of my principles for the prototype was to keep everything as interpretable as possible, which is already kind of tough. But refactor later. All right, so let's create this instance method. All right, so we have a map of material. By color, if you go for plus and minus, doesn't really matter the perspective. The operator is the same. No, what are you expecting out of some material? Oh, I just want to get the material, the count of material for either side. Because ultimately the material will just be one input to the evaluation. Although, yeah, as a start, it's the only evaluation we have. So for let's look at piece map again. Okay, a piece map is indexed by color of piece and is a set of numbers. All we need is the length of the set times the value of its key, right? So pieces get removed from the set when they're captured. Yeah, it's just the sum of the valuable pieces of the available pieces. All right, so key value in piece.map. What I can say is if key in piece dot black pieces length of value, let's say black sum plus equals length of value, and that's the opposite of plus equals. All right. Black sum is equal to the length times the value of, all right, so here's what I'm going to do actually. So what I'm tempted to do is actually make a sort of a redundant dictionary just so I can reuse this black piece, white piece, and still have a hashable type. All right. Refactors lie ahead. But the reason I'm structuring like this is so that I can just, as I'm iterating through the piece map, I can use the same constants. Although I guarantee if you look at any chess engine out there, none of them have this. Every one of them, I'm sure, has like just what I just had in it, and now I'm going in this route. But it's hard to think and talk on stream. So I'm going to do it this way, and then I'm going to come back here. Now black sum is equal to length of v times the name of this thing, which is piece to value at key. So that's why. Basically, it's keeping me from an additional step where it's like if key is equal to black dot whatever, black piece dot black pawn, piece to value pawn. And what's up with this not coming in? There we go. Imports. This is going to return an int. I feel like this should return a float, really. Because here's the next thing to think about. I was going to say float because people say bishops are worth like 3.5 sometimes. And what that led me to think is maybe pieces have relative value, like bad bishops are technically worth less. Yeah, we don't need the kings. I thought about referencing it as infinite because in any calculation that we might use for evaluation where we're trying to figure out whether or not it's feasible to give up a piece, we may use the material value for that piece. And in any algorithm where that's implemented, the king will always have infinite value, in which case it will never be worth it to do something that gives up the king. That's my long-winded thought behind why that's maybe needed. So I'm going to leave it there, but I agree that it may not be needed depending on what I end up with there. It's just a half-baked idea. I was thinking about how chess.com built four-player chess. And how in a lot of my... So a few things. When I first started the chess engine, I made the board and everything. Like the constants are all like, you could change the constant to like change the length of the board or whatever. So that theoretically you could use like a 12x12 board and still have the same rules. That fell apart pretty quickly once I started creating stuff like the Knights bitmap and it's not necessarily true. It would still work. But yeah, the directions of things. Anyway, long story short, there's some places where the initial flexibility was not even really needed. And then I started thinking about four-player chess, and I have all these places where it's like, in this code, where it's like if white, and then there's no else, and then you just do whatever the other side is, or if black. But in four-player chess, there's four colors. That's right, trying to do king times. You're right, you're right. What happens when we do that with numpy? That's just going to be 1 or 0 times numpy infinity. No, it's only ever going to be 1 times numpy infinity because we always have... We can just pass over the king piece when we're summing the material. That's a good point. So we're not even going to run this, but I'm just curious as to what this is. So that's infinity. There's this... that is not a number. Man, you guys ever see Gary Bernhardt's watt talk on JavaScript float and number representation? It's pretty funny. This is what I was thinking of. Okay, let's make sure we don't run into that bug that Alvaro just mentioned. Where are we at? Some material for key value piece. if key is in, I could deep copy the piece map and remove the king key, but that looks nasty. So what I'm going to do is say if key is nice. I'm glad that you've seen that. Yeah, I've seen a few of them too. I really like Gary Bernhardt. Actually, he maybe you've seen this. The Destroy All software screencasts that he makes are really good too. A little expensive, so I don't have a subscription, but I have had a subscription in the past, and he does some pretty cool talks. These aren't the ones that are. These aren't as comical as WAT, but so he does some on testing from scratch. The series on computation is really interesting. Since I didn't have a computer science degree, so that was kind of fun to do. Um, but a bunch of these short, sort of like 10-minute podcast or screencasts, highly recommended. But I'm glad that you've seen that one too, Alvaro. All right, so what I was going to say, if key is equal to, if key in, what? Just going to pass, or should I continue? If key is in the black pieces, otherwise we do this one. And this is just going to be an int for now. Right. So, oh, that's right. My thought on the why maybe not, why maybe an int and not a float. I think it could go either way because first my thought was, okay, yeah, bishops could be worth, like, just say like 3.2 pawns or what have you. And then like they could be dynamically weighted depending on the position. So we should be able to heuristically say that a position is closed or not if the center is occupied by pawns, for instance. And so then we could say like, oh, given that the position is closed, the weight of the bishop on the squares blocked by own pieces is the quote-unquote bad bishop, and that should be worth less. But then I thought, isn't that really a positional evaluation on top of like the raw material? And would it maybe be simpler to still always store the raw material? But then the other side of me is saying, well, it's kind of six of one, half a dozen of the other, if you will. Like it's sort of a matter of when you decide to sort of stack the evaluation pieces together. So my simplistic side is saying just have something that you can tell what the position is at any point in time, and then maybe build on top of those heuristics to modify. As opposed to try to modify in place, maybe even just from a like it's hard to say architectural because this application is so small, but even from just like a changeability perspective, it might make more sense to have a simple sum material function or method in this case that doesn't take any other features of positional evaluation into account, and then we can compose those later. So I think that's the way I'm going to go for now, but I'm just kind of thinking about it out loud. Oh, and I didn't even bring color into this. All right, so here's what I'm going to do. I'm going to return a dictionary here. And we're going to do this. material balance. The IDE is slow because it's like, why do you have a 1200 line Python file? My IDE is like so slow right now to catch up. Alright, so do material balance at color black is this. Material balance at color white is this. And we're skipping kings because of the infinite value of them. Even though technically we would only ever get inf back. But what it would do is just make the material value of either side always infinite. And that is an oversimplification, isn't it? Alright, so now this is returning a dictionary. So we have this property. Technically, properties shouldn't really have get prefixes. Piece in black pieces, increment black. And then otherwise I'm doing this. I need to do, yeah, sorry. Very good catch. Well, I don't know if I even need the property though. This is the property, really? So what I'm going to do is go down here to this. With properties, I kind of don't like to put a get verb in front of them because properties in Python are kind of like disguising the fact that it's a method call, and you access them as if they were just attributes, but so it's sort of just like a computed property. So I'm going to rename this as well as occupy squares by color. Refactor. So let's see what that actually changed really quickly. Okay, so it's an own piece targets. Some dupes in there. How long have I been going? Okay. Yeah, I'm super excited for where this is going to go next. So like here, without search even implemented, now we have a way to say, oh wow, we could have another property that just sums the material balance, and that's our first technical evaluation of a given position. I think the evaluation stuff belongs in another class, another module, I should say. Here we'll always make this a float, even though we're only working with ints right now. What we want to do is say white material is some material. Alright, so we'll say material balance is equal to some material. And technically, again, if I replace the verb, switch the verb, it becomes a better name for a property. So we'll say material sum. And do the refactor. There's only one place when it's used, which is right here. And so what I'll say is material balance is material sum, material balance color dot whites, and then color dot black. And then we say white material is this, black material is this. And now we can just return white material minus black material. This is the simplest evaluation that we actually have. So let's play with this in Jupyter. Let's see. Here, clearly. I gotta put dot strings on everything as well. Alright, so let's see what happens when we play with this in Jupyter. Overwrite, that's fine. Alright. Kernel, restart and run all. These are my unit tests. Okay. The fact that they're unit tests is a joke. I'm just saying these are the only operating. This is the only way that I'm exercising the code. Alright, so we got a bug on constants line 260. What? Invalid character. What am I missing? What? That is so weird. There was like some hidden character in there. Okay. So let's run everything. Alright, unit tests are passing. Asterisks. So now what I want to do is we can now technically get the material evaluation of the position. I could get really fancy. We could get really fancy with the printing of this too, to like print the evaluation on the right side of the board, which would be really useful actually. So maybe I'll implement that. I'll probably play around a GeoGuessr or chess. Is anyone challenging to chess? No one is challenging. All right. So if we say position, oh man, if I say position. Current evaluation. Check it out. 3. Because in this position, white is up a piece. So if we make another move here, actually, black pawn b7 c6. All right, so let's replay this. And instead, we will play this move. Yeah, that's actually a good point. Maybe it was in the piece representations. All right, so let's capture instead of move the king. Get rid of this nonsense. Starting that on. Wait, bishop. Did I get rid of what I tried to paste? Okay, whatever. We'll do this. Move 10. Now we're going to do square b7. Takes square c6. And it's a black pawn. Alright, so black just took the bishop. And now let's get the material evaluation. It should be 0. Nice. Alright, so we have our first really naive evaluation, which is just completely based on material. And has no positional factors whatsoever. Alright. So let me clean up the notes here. I'm going to even get rid of the to-do about mutation because there are some things that are going to come out in a refactor here soon. Threefold repetition. 50-move rule. Dedupe from board module, that's actually still needs to be done. We also need to dedupe the evaluation function. The evaluation function is actually, what did I call this? Evaluate move, actually. Unit test, king and checkmate is done, although I can't guarantee it doesn't have bugs. Push FEN to the game stack. We could actually do that. Should we generate move from the board? I'm trying to think of what this was. Alvaro brought this up. I'm okay with generating the move like we do, but I'll just leave it there and we can leave it there for now. When it comes to move evaluation, here is what I'm talking about. So I have this function evaluate move. It actually it starts to look like a chess engine for real. I'm glad that you think so. I'm happy though. It means we can kind of play chess with it. With the exception of stalemate, which I need to look up here. Stalemate should actually be pretty easy to check. Because we can check if there are no legal moves for one side, immediately check whether or not that state is also the same for the other side. Also, no checkmating pieces draw. So when we get king and knight, only when we get king and bishop, and only king, knight, and king, bishop, king. These are draws automatically because there's no way to mate with just a king and a bishop or just a king and a knight. Okay. You know what we can do that would be really easy is game. So while not self dot is over, self dot input self dot color remove to move. Let's see if this works. I haven't touched this in a little while. Alright, here's what I can do for the remaining time here. We can actually implement game so that I can technically play this from the terminal, for instance. So, if not, self.tryparse move invalid move format, tryparse move is doing what? It's passing. Okay. If move not in whatever, return false. So now what I can do is take a look at where I parse moves in the actual position. Okay, so here's what I'll do. The way that player needs to play is to type in we'll call this is console piece notation. Oh, wait. Let me think about this for a second. Pawn, bishop, knight, king, rook, queen. Oh yeah, I should be talking when I'm doing this as well. So what I'm trying to do here is, first of all, move this down to the bottom. And now I'm trying to get it so that we can play the game from the terminal, like actually run the game function. And so the way this is going to work is we try to parse the move, and we're going to say if move is not in the console piece notation map, and in fact, I'll just make sure it's cleaned up a little bit. We can say move.lower.strip. Won't that work? So doesn't like this work? Yeah, so strips left and right, I think. Yep. So this will mean if someone for some reason does like this, white queen or something like that. Oh, and it's always just going to be their piece, so they could just do queen like this, or it'll come out like that. So we can feed the move like this. Here's what I'm going to do. I'm going to move this to game until I have my head wrapped around how I want to do this. So game should know about position. So what we can say is when we're trying to self-parse a move, the user's going to put in something like pawn or queen. They want to say something like, into the terminal, they want to say something like pawn e2, e4 as inputs. What's UCI input, by the way? And apparently the Universal Chess Engine interface is not the most popular UCI that exists. Alright, what does input look like? Might as well make it to be the UCI standard input format anyway. All command strings the engine receives will end with new line. Also, all commands the GUI receives should end with new line. Note, new line can be this hex representation or any combination. The engine will always be forced to blah 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 blah. Oh yeah, there's this own bug situation that hasn't been programmed for. The chess engine receives a command which it's not supposed to come, for example stop, when the engine is not calculating. It should also just ignore it. Move format. The move format is in long algebraic notation. A null move from the engine to the GUI should be sent as 4 zeros. Examples e2, e4, e7, e5, e1 shows short castling, e7, e8, queen for promotion. Okay. Yeah. Sad. So this is interesting. Do I really have to parse it like this? Which would make my game responsible for determining that e2, like there's a pawn on e2, for instance. I would much rather say p e2, e4, for instance. All right, I'm not going to program all of the UCI into it. I just want to program the move format. I have a theory that the quality of a web page on the internet is inversely proportional to the number of lines of CSS in terms of quality of information. So the less CSS, usually the better, the more valuable it is in terms of information. But the one piece of information I'm looking for here is not looking good. I don't see anywhere in here where it says the way to actually move a piece. I assume piece means column. Wow, so I have to actually build the engine to determine. That's gonna be kind of tricky. It's not that bad though, because we have the piece map, so we can just identify what piece is on that square. Okay. Can someone help you with pip install PyBitcoin tools? Where are you getting an error? On PyCharm. A couple of things there, SEO Greg. First of all, let me put on Do Not Disturb mode. Basically, you're not crashing the show. It's all good. Just hit the like button and all will be forgiven. I'm just kidding. Whatever. In PyCharm, I guess you may want to make sure that the interpreter that you've set up to use in PyCharm is the one in which you've actually installed PyBitcoin tools on. Been at this all day. I've also been coding all day, so I apologize if I'm not totally sharp. Okay, thanks, Alvaro. Yeah, I'm not sure. But yeah, Greg Johnson, if you want to look at the PyCharm preferences and then head down into the languages and frameworks. Actually, where is this? Build, execution, and deployment. Python debugger. Let's see us. Actually, where is this? Python interpreter. Sorry, it's under project. So I suspect, Greg, if you're having problems importing your library inside of PyCharm, that the Python interpreter you're using isn't correct. So you can use PyCharm to automatically set up your virtual env, but what I would probably do is this. All right, I'll take a 5-minute hiatus here to try to debug SEO Greg's thing real quick. I'm going to make a new directory here called my bitcoins. Cd into my bitcoins. What I would do, Greg, if I was starting from scratch, there are a couple. You could use VENV, which is built into Python 3, but you could also just as easily use virtualenv. So I created a virtual env, which creates this directory env, which you can see here. Then you could do virtual env, or sorry, you would do source env bin activated, right? All right, yeah, just hold on. I think we'll get there with this maybe. I'm going to try it. 3.9, so you do have the latest Python. I'll see if I can get on Python 3 as well. 3.9, I mean. So if you do deactivate here, it'll turn it off. But if I do virtually env Python 3.9, hopefully it'll pull. Yeah, I don't have Python 3.9, but this should also work, I assume, unless there's an incompatibility on your what's it called? PyBitcoin what's your library called? I need to scroll up to see it now. Hide Bitcoin tools. All right, so you have an env. I run source env bin activate. You can also use venv, which ships with Python 3 and Python 3.9 as you have. Then what I'm going to do is, you'll see if I do pip freeze, I have no packages installed. All right, so what you do is you'll pip install with the virtually env activated Bitcoin tools. Is that right? Okay, so it installed. If I run pip freeze here, I can see that I have Bitcoin tools 1.1.15. Then what I would do is create or open the directory. We'll open this in a new window really quickly. And I'm going to try to get back to the chest real quick. Come here, my Bitcoins. We're going to open this one. I'm going to do it in a new window, which is down here on my machine, so I'm going to pull it up. Sorry, just switching monitors really quickly. Alright, so what I'm going to do is make a new Python file called whatever, main.py, import Bitcoin tools. And this works because I have a virtually env in this directory. If you need to change that, you should head into preferences and then into project my Bitcoins, Python interpreter. It should find your env in here. Nice, you got it? All right, sweet. Sorry that you spent a lot of time on that. Hope that was helpful. All right, cool. Yeah, don't worry about it. All right, so when we're trying to parse the move, I think Alvaro was correct in that UCI is going to take in this long algebraic notation or whatever, which, if I could find UCI again, I guess I lost it. All right, so let's see here. Yeah, that's the way it goes sometimes, Greg, for sure. It's like you go down the rabbit hole and that kind of stuff sometimes, particularly in Python. Like the module system is a little, I know your problem was related to third-party libraries, but the module system can also be kind of tricky. All right, so console piece notation map is so we're not going to have a dictionary. We could. It'd be a pretty big data structure because, well, it'd be a simple data structure, but it'd be a lot of data. They call it long algebraic notation, but then they state that it's not. Yeah. Programmers and naming stuff. My favorite one of bad naming is one that I just always get confused. Like, well, I'm not going to go down I've been down too many rabbit holes. I'm just going to keep forging ahead. But in front-end development, in CSS, justify content and align items rather than just call it flex X and flex Y, for instance. or flex primary and flex secondary. Why would you name it two completely different things? Alright. So, where was I now? Oh yeah, we need to write a parser. This is where like some stuff is starting to get fun. Now at least I'm not thinking about the rules of chess, which is the only thing I've been thinking about for like the last 2 weeks. UCI input parser. Alright, I'll make part of a parser and then I'll play. By the way, Alvaro, thanks for looking that up. UCI input parser. Def init. It's bigger. So I was going to go down the route of doing additional evaluation, but I need to read up more on that. So we're going to work out the game. Parse input, user input, pass. If I could type today, that would be great. Watch this out. A form of long algebraic notation without piece names is also notably used by the UCI standard, which is a common way for graphical chess programs to communicate with chess engines. Wow. Why wouldn't they call it short algebraic notation? Alright, so what we're going to do is receive the user input. Every user input has a regular expression, parsable, obviously, syntax. So we want to make capture groups for the from square and the to square. And then in the case of promotion, as they said, like alright, so the way that it would look is like E2, E4, or E7, E8, queen, C7, C8, knight, whatever. What would be a bishop move? Bishop G1 to C4. Alright, so we gotta have capture groups for letters A through H, and then numbers 1 through 8, and then second capture group of the same. Short means there's no from clause except the ambiguous moves. I see. A through H, 1 through 8. And then we have an optional capture group of, it can be queen, knight, rook. How do we do an optional look ahead in regex? So yeah, you need a parser to find the piece on the square to translate. It shouldn't be that hard. Yeah, absolutely. This is where the piece map, the piece representation comes in handy. So you got queen, knight, rook, bishop, except we can do it like this. Alright, so there's my regex, I suppose, for parsing the inputs. Let's make sure that no garbage can get in here. So like I7 to E1, knight. I see. We need to make sure that this only, well, we can do this without the fancier regex. We can just make sure that we can assert that there are capture groups for the first and second capture group. Alright, so Python, yes, still valid. Okay, so what we'll do then is we'll say, actually we can compile the regex, so we gotta do import re, and then self.input pattern is equal to re.compile. I can type. Okay, so if not user input dot match, isn't this the syntax? Oh, I think we have to do self.input pattern dot match user input. I don't know, I'm just kind of winging it right now. We should do bool or move. And then, how do we get capture groups in Python? Let's just take a look. Import re.compile r blah, and then blah, and then this will be the pattern, and then we can say result is pattern match e2 e4 results. What do we have on results? I see groups. Nice. Actually, Python's great for regular expressions. Okay. And then technically, if I do something like e7 to e8 queen, I just thought of another case. By the way, this doesn't work, does it? What about this? Yeah, none type has no attribute groups. So we need this. 788 queen. Alright, so technically it didn't get the third group from this. Oh, the OR for castle is always one letter plus one number, so 1, 1, or 2, 2, both an optional. Oh, wait. Oh my gosh. I keep getting, I keep self-rickrolling myself by typing in UCI and then expecting it to be what I want. Yeah, so I can interpret that. This is the other thing that I'm having trouble with. Let's get back to the regex thing. So I want these to be. Why does it not catch the third capture group in like the case of queen, for instance? Oh yeah, I see what you're saying about the size. So that's not it, right? No, it's size is always one letter plus one number. Yeah. So why didn't this work? Actually, single character one time. Yeah, I know searches. Oh, Google. Google should know enough about me right now that I'm either searching Stack Overflow or chess. I mean, might as well just make a personal index for me. And then the size of this, how do we limit it from being like, oh well, it doesn't matter, like, but I don't want it to be like this capture group. I want to be exactly too long, right? This capture group I want to be exactly too long. This capture group I want to be exactly one long. Why doesn't that work like I expect? This one should always work like I expect, but this doesn't work like I expect. Capture group length. Matches exactly one time, meaningless quantifier. Yeah, that is meaningless, but I want the total length of the capture group to be exactly 2. A repeated capturing group will only capture the first or the last iteration. Put a capturing group around the repeated group. Capture all iterations. Ay, ay, ay. This gets us close enough, but does it fail for cases like, let's see. Yeah, I do want to be case insensitive, which I think is like question mark I or something like that. Forward slash I. Or we make case insensitive. Question mark I, right? Question mark I. Forward slash I see. Question mark I, that's what I'm familiar with. I was going to too lower it anyway in Python, doesn't matter. I see what you're saying here for this 0, 1. But like here, I want this to be explicitly 1. And I want the capture group to only capture if the total length of everything is 2. Can you do this? That doesn't make any sense. Assert length of capture regex. And I would love to do it without a look ahead. Whenever I read look ahead or look behinds and I come back to them later, I always forget like which direction they're looking, by the way. So I'm just gonna forget that. Maybe and I'm not gonna Google UCI again, that's that way, but if I do UCI chess. Regex. Haha. Oh man, why does the regex look exactly like the one that we just made? This doesn't work exactly like I want it to. By the way, what program is this? Emacs chess. Emacs is like another planet that I haven't spent much time on. Okay, this is a regex that I wish we could use, but that's not UCI format. Alright. Oh, that works for you? So what do I have different here? Because I tried this once, length 2 once. Is this piped-in what I think it is? But now I want to do queen, knight, rook, bishop. Can I try that one? Oh, my stream thing won't let me copy and paste that. I'll type it. But I want this one. Almost gets what we want, except with the capture group I always get the last two. But you're saying do something like A through H1, 1 through 8, 1, 2, or oh, just or the whole thing. Rook, knight, queen, bishop. One. Alright, I think I messed up on your pipe here. A through H1, 1 through A1, 2. Yeah, that'll catch the same thing, I think, as this. And then we just use Python to get the capture groups. I guess what I would be worried about is a case like this. The user types in like EF2. I kind of would want to throw that out. I'm afraid I'm going to have to do a look ahead to make sure that what follows every letter is a number. A positive look ahead. See, this should capture the same group. Am I missing a capture group? Yeah. So, there we go. But I'm afraid I'm going to have to do a positive look ahead on the letters. Regex, positive, look ahead, number after letter. How do you sequence groups? It's just the order. It's just the order of the parens in the regex. Like in Python, it'll just come out in the order that you put them in. Look ahead and look behind. Oh man, I've so been to this website before. I feel like I've been here. Positive and negative look behind. I want a positive look ahead. I need a regex just to find out what's valuable on that page. Such that what immediately follows the current position is the string foo. Alright, so what I want to do though is assert that what follows every letter is a digit. So we can do question mark equals \d, simplify things. So we already assert that it's 1 through 8. So one time look ahead / D should be the case. Let me just spot check this. Like if we said it should be 7, right? So sorry, that works. Technically, I could make sure that it is 1 through 8. And I could assert that this is the beginning of the line, right? This is the end. Yep. All right, this is all I really need, actually. I don't even need the positive look ahead, I don't think. Because we're asserting that the letter happens once. Although this, I need to make sure that there's a positive look behind of length 4. So what's the positive look behind? There you go. My dog has come to visit, meaning I should probably wrap things up here soon. Alright, so we want this. Here we want the negative look, or the positive look behind to not be foo. But to be a digit. And technically this could be 1 through 8. And we need this to be optional as well. So then why doesn't that work? Oh, I think I was onto what you're saying about your regex previously. Is we want actually all of this. I think I'm onto what you're saying now. Or all of this. Yep, that does it. And I could actually get a little bit trickier here and make sure that we can only promote if, when we do a promotion, that it comes from it goes on the 8th square. So now, actually, we've got the rules of chess baked into our regex. Because, for instance, if I try to go like C6 to C7 knight, it's not even a legal move ever, even from the regex perspective. Sweet. Alright, this is our regex. It's probably not golfed. It could probably be a lot shorter, but constants. Call this the UCI input regex is equal to R, and then all of that. I'm glad that we wrote that ourselves, actually. Gotta have some fun. Okay, nice. Very good. Alright, I'll finish the parser offline. The very next stream will be pure search tree evaluation. Oh yeah, and I don't know whatever happened to this guy who needed help with his bitcoins, but I hope that he's maybe he'll become a millionaire. And then he'll say, I got my program working thanks to the PyCharm tips. Alright. And UCI input regex for parser. Yeah, that way we don't have to bother doing any move calculation. If we can have simple enough, it didn't really overcomplicate anything in the regex beyond what it already was. So we can just tell them right away that that move doesn't make any sense. I'm not even gonna work at it. Yeah. Lumi Girl came down for the stream. All right. I'm gonna end things with a quick game of GeoGuessr. Alvaro, man, at this point, you gotta get some sleep, I imagine. Because now I'm getting tired and it's like only 9 p.m. here. By the way, thanks again for all the back and forth on this. It's been really fun. All right, so let's see here. Play one game of Diverse Worlds. All right, so let's play. 2 minutes seems good. Dog's name is Lumi, which is a Finnish word for snow because she's a husky and she likes the snow. We get a lot of snow up here in Wisconsin, in the U.S. All right, Barstow Needles. This looks a lot like the southwestern United States. I'm not familiar with a place named Barstow or Needles. This looks like New Mexico or Arizona, maybe. Oh, San Bernardino County, so that's in Southern California. Question is where in California? Yep, have a good night, Alvaro. Thanks again. And I'll schedule the next one for sometime, probably after the holidays, maybe on the holidays. I don't know. But have a good Christmas and holiday. See ya. All right, isn't this San Bernardino County down here? I think maybe it is. I could be completely wrong. So we're headed south on this road. Actually, that's as far as it goes. We've reached the end of Google Earth. All right, what road are we on? We have 10 seconds left, and I totally just blew right by the road. So I have a feeling we're relatively close. Okay, we were 112 miles away. Okay. So no longer in the U.S., I think. The sun is really in the south. Sorry, in the north. So we're pretty far south wherever we are. I'm guessing we're in South America, but I Not sure where. I'm guessing that we might be in Bolivia, maybe? Oh, it's way too mountainous where I just dropped. Maybe Chile? We gotta be really far south, don't we? I don't see any mountains, though. Alright, so we get some signage up here. I always blow past the signs with like 5 seconds left. Oh no. Ran out of time. Ugh. Not even the right continent. But Southern Hemisphere was correct anyway. Okay, where do we look like we are now? This looks a little bit like I'm thinking. Yeah, I was getting ready to say Nova Scotia. Now I see the Canadian leaf up there. My guess is that we're like up here in Nova Scotia, just judging by the looks of things, but I can't be certain. Yeah, hard to say. Now it's kind of looking almost like Pacific even, so it could be on the wrong side of Canada. So my gut said Nova Scotia, but the more I'm looking at this, I'm kind of thinking that we might be all the way over in British Columbia. It's super hilly as well. So this is going to be a bit of a gamble. But given that we're on a pretty big windy hill and I'm seeing a lot of evergreen trees, my guess has shifted to the opposite coast of Canada. Even though just the general vibes at first to me seemed kind of like Nova Scotia. So we'll find out. And I should have stayed with Nova Scotia. Go with your gut, I guess, is the lesson. Okay, bad round of GeoGuessr. So we have some red soil, pretty green leafy trees. We're driving on the right side of the road, it looks like. Although no, I can't tell because I wasn't able to pass a car up here. I don't know about this one. Can't get much of a read on the bag or anything. I'm gonna have to make a decision here. I'm thinking it's like tropical. This was a tough GeoGuessr. For a while there, I was thinking Brazil, but I don't know that that's going to be completely correct now. Maybe Venezuela. Alright, I'm giving up on this one actually. It was Brazil after all. Man, I just learned a lesson to go with my gut, and then I went against it again. Alright. Very distinctive architecture here. It looks really beautiful wherever we just landed, actually. Let's see if we can get a read on this sign here. So we have some sort of Mediterranean-looking architecture. And can't really read what's on that sign, to be honest with you. Maybe here we'll get a better read. Sandgasso? I don't know. So we definitely landed in a town this time, which is kind of refreshing. Wow. Pistupnik Philip. Ir etwas anderer. So maybe that is, I mean, that obviously looks a little bit like German, but I suspect maybe it's not. Baumschul Fleischacker? Sounds like German, but it doesn't look totally like German. Is it Austrian, maybe? I don't know. I'm going either Austria. Ooh, it could be Liechtenstein. I'm gonna guess Austria, though. Okay. Yeah, it was Austria. Southern Austria, though close to Slovenia, which explains some of the Mediterranean vibe. Okay. I'm gonna play one more GeoGuessr. This was a pretty long stream, actually. So code has been pushed, by the way. I'm gonna run out of time on that GeoGuessr. Yeah, we're all good on codes. The next stream I'll be building the UCI parser, input parser, and working on search and evaluation. Okay, looks like the Dutch flag back there, maybe. So my current guesses were in Netherlands. Is this what Holland looks like? I wish I knew the license plates. I wish I could stop zooming past signs as well. It looks a little Dutch. 2 U's in it like that. Alright, so we're going to put this in Holland somewhere. Is that what I want to do? Sure. But where, I'm not sure. Apeldoorn. So we could also be in Belgium. Northampton, UK, Big B. Also, what's going on, Big B? Good to see you again. We were indeed in Holland. You know, the first thing I thought when I saw this sign, the first thing my brain went to was the "This is fine." This is fine meme. Yeah. So look how similar that looks to this sign. Okay. Evita incendios. forestales protege los bosques. I think that translates to this is fine. This looks maybe like Mexico, like northern Mexico. So that's my guess, but like Tijuana. Of course, it could be completely wrong. This could be somewhere in South America as well. Pretty sure that was Spanish and not Portuguese that we saw on the sign. Alright, but that's going to be my guess. It's a little bit of a risky guess because if it is somewhere else in Mexico, then I should put it closer to the centroid. But I'm going with it. Oh, yeah, should have brought it closer to the center. At least we got the country right. Alright, this looks beautiful as well. Map C7. Map C7. Is this company? Le Safre. So this is France. I wonder if we're in like northeastern France. Like Strasbourg. Alright, I'm getting a little bit sleepy, so I'm just gonna guess. Maybe we're in Bulgaria, completely wrong. Getting rusty here. Alright. Yep, so I see some Cyrillic. It's very arid. See some mountains in the background. The mountains are to our south and to our north. So we've got Cyrillic mountains to the south and mountains to mostly the south. Look at that, map C again. So, could be Kazakhstan, be Mongolia, be Kyrgyzstan. Let's see here. I don't think we're in Georgia or Azerbaijan. I think we might be in Kyrgyzstan. No, we're probably not in Kyrgyzstan. Maybe we're in Mongolia. Kyrgyzstan, Kazakhstan, Mongolia, not sure. It's such a huge region. And we were in Mongolia. I never learned my lesson. Alright, last one for the evening. Some beautiful hills. Looks a little bit like certain parts of the US, but pretty sure that we're not in the United States here. Looking at this architecture and the vegetation, actually. And the cars as well. Interesting. Wish I could get a read on these flags. I honestly have no idea where this is. Where could this be? Oh, Turkey? Really? I don't. I mean, that's not a Turkish flag, but